You know what's genuinely insane about LS engines? They make power by accident. I'm serious. Engineers at GM basically stumbled into creating an engine so overbuilt that even bone stock, untouched, warranty-intact examples are putting down numbers that would have been considered race-only territory just 20 years earlier. We're talking about pushrod V8s here, technology that dates back to when color TV was considered space age, and yet somehow these things are embarrassing modern DOHC designs that cost 3 times as much. Never heard of an LS making too much power? What if I told you that GM's lawyers actively tried to suppress dyno numbers because they were afraid of liability issues? Yeah, you heard that right. So with that out of the way, let's talk about what makes these aluminum blocks such freaks of nature. The LS1 debuted in the 1997 Corvette, and right out of the gate, it was underrated at 345 horsepower. Underrated. GM claimed 345, but independent dynos were seeing 320 to 330 at the wheels, which means closer to 380 at the crank. That's a 35 horsepower discrepancy that GM just pretended didn't exist. Why? Insurance rates, warranty claims, and the very real fear that they'd created something too good for its own good. But here's where it gets interesting. The architecture of the LS wasn't actually revolutionary. Deep skirt block design? Been around since the 60s. Cross-bolted mains? Old news. 6-bolt main caps? Please. What GM did was take all these proven concepts and execute them with a level of precision that was borderline obsessive. The bore spacing, for instance, 4.4 inches, borrowed directly from the small block Chevy. Conservative, even boring. But that conservative approach meant they could make the cylinder walls thicker than a milkshake, and those thick walls meant boost. Lots and lots of boost. Now check this out. The factory connecting rods in a standard LS1 are good for about 900 horsepower. 900. From factory rods. In a Corvette that came with a cassette player. The stock crankshaft? Nodular iron in the early ones, strong enough to handle 1,000 horsepower if you're feeling lucky. Even the supposedly weak powdered metal rods in the later engines are good for 600 wheel horsepower all day long. These aren't forged internals we're talking about here. This is mass production stuff, churned out by the thousands, and it's stronger than most aftermarket racing components from the 1990s. You're probably thinking this is all bench racing nonsense, but the evidence is overwhelming. Go to any drag strip on any given weekend and count the LS swaps. Better yet, count the stock bottom-end LS cars running 10s. I'll wait. The LQ4 and LQ9 truck engines are particularly hilarious examples of this phenomenon. Iron block 6.0 liters that were designed to haul landscaping equipment, and people are slapping turbos on them and making 4-digit horsepower without opening the engine. Not replacing pistons, not upgrading, rods just boost and prayers, and somehow these things survive. The cathedral port heads, which everyone considers inferior to the later rectangle port designs, flow 250 CFM stock. That's 1970s pro stock territory from a head that came on Grandma's Tahoe. Port them mildly, and you're looking at 280 CFM, enough to support 550 naturally aspirated horsepower. The LS6 heads, with their better chambers and improved ports, will do 290 CFM with nothing more than a valve job. These aren't race heads. These are emissions-legal, warranty-backed, daily driver heads that flow like something out of a NASCAR shop. Furthermore, the intake manifold design is so good that aftermarket companies struggled to improve on it for years. The truck manifold, that ugly plastic thing that looks like it belongs on a dishwasher, flows better than most aftermarket intakes from the muscle car era. The LS6 intake manifold became legendary because it was essentially perfect right out of the box. No porting needed, no tricks required, just bolt it on and make power. GM's engineers had accidentally created something that the aftermarket couldn't meaningfully improve upon. Let me tell you about the valve train for a second. Everyone mocks pushrod engines as old tech, and sure, overhead cams are theoretically superior for high RPM operation. But the LS valve train is a masterpiece of simplicity. The rockers are shaft-mounted, not stud-mounted, which means better stability at high RPM. The push rods are way shorter than traditional small-block Chevy pieces, which means less deflection. The valve springs are beehive-shaped, which reduces mass and allows for higher RPM without valve float. Stock LS1 valve springs are good to 6,500 RPM. Stock LS6 springs will take you to 7,000. The LS7 springs, 7,200 RPM all day long, and these are hydraulic roller setups, not solid lifters. Meanwhile, the oiling system is overbuilt to an almost comical degree. The oil pump is a gyrotor design, far superior to the traditional gear pumps. The windage tray is substantial enough to work as armor plating. The oil passages are massive, prioritizing volume over pressure, which is exactly what you want for longevity. Even the PCV system is over-engineered, with dedicated passages cast into the valley cover to prevent oil consumption under boost. It's like GM engineers were planning for boost from day one, even though forced induction wasn't even on the official radar. The combustion chamber design deserves its own discussion. The 15-degree valve angle isn't particularly aggressive by racing standards, but it's perfect for street engines. The chambers are compact, usually around 61 cc, on cathedral port heads, which means good compression, even with dished pistons. The spark plug location is nearly ideal, the quench is excellent, and the flame travel is short. This translates to an engine that'll run on 87 octane if you're cheap, but responds beautifully to good fuel and aggressive timing. The knock sensors are incredibly sensitive, allowing the ECU to run right on the edge of detonation without grenading the engine, which brings us to the ECU itself. The LS1 PCM was revolutionary for its time. Wideband oxygen sensor capability, individual cylinder timing control, incredibly sophisticated knock detection, and enough processing power to run complex algorithms. Tuners discovered they could push these engines incredibly hard because the computer was smart enough to pull timing when needed. This wasn't some crude batch fire setup from the 80s. This was modern engine management that could adapt on the fly to changing conditions. But more on that in a bit. Let's talk about why GM deliberately underrated these engines. Turns out, the marketing department and the legal department were in a constant battle. Marketing wanted big numbers to sell cars. Legal wanted small numbers to avoid liability. The engineers, meanwhile, were building engines that exceeded everyone's expectations. The LS6, rated at 405 horsepower, was actually making closer to 450. The LS2 at 400 horsepower was really around 430. The LS3 at 430, try 460 or more. Every single iteration was sandbagging, and everyone knew it. Insurance companies caught on pretty quickly. A 1998 Camaro SS with the LS1 was supposedly making 320 horsepower, but insurance rates were priced like it was making 380, because it was. The insurance companies had their own dynamometers, and they weren't stupid. They knew these cars were faster than advertised, and they priced accordingly. This created a weird situation where GM was lying about power numbers. Insurance companies knew they were lying. Consumers knew they were lying. But everyone just pretended the official numbers were real. The aftermarket response was immediate and overwhelming. Speed shops discovered that a mild cam swap would net 50 horsepower. Headers and exhaust, another 40. Ported throttle body, 15 more. Cold air intake, 20 ponies. Suddenly you had a 500 horsepower street car with bolt-ons and a tune. No bottom-end work, no forced induction, just breathing mods and valve timing changes. The LS1 Camaro guys were running low 12s with nothing more than long tubes and a cam. That's faster than most supercars from the 80s. Here's where things get crazy. The Junkyard 5.3 LM7, the most common LS variant ever made, has become the darling of the boost crowd. These engines were in every Silverado, Tahoe, and Suburban from 1999 to 2007. Millions of them. You can buy one for $500 at any salvage yard, slap a turbo on it, and it'll make 600 wheel horsepower on stock internals. 600. From a junkyard motor that was designed to tow boats. The ring gaps are too tight for serious boost, the pistons are cast, the rods are powder metal, and none of that matters because the design is so robust that it just doesn't care. I've personally seen LM7s with 200,000 miles getting turbocharged and making 550 wheel horsepower daily driven. No rebuild, not even a gasket change, just boost and a prayer. The piston ring lands, which should be the weak point, somehow survive because the ring gap fills with carbon and self-clearances. It's engineering by accident, but it works. The head gaskets, which are multi-layer steel, will hold 20 pounds of boost stock. The head bolts are TTY, supposedly single-use, but guys are reusing them with boost, and they hold fine. Essentially, what we're dealing with here is an engine architecture that's overbuilt to the point of absurdity. GM engineers, whether by intention or accident, created something with so much overhead that it makes traditional hot rodding seem quaint. Why port heads when stock ones flow enough for 500 horsepower? Why forge internals when stock ones handle 600? Why upgrade the oiling system when the factory one handles 7,000 RPM? The old rules don't apply anymore. The real genius, though, is in the details nobody talks about. The water pump, for instance, is driven off the camshaft, not the crankshaft, which means it spins at half-engine speed. This reduces parasitic loss and cavitation at high RPM. The alternator is mounted low, improving weight distribution. The starter is tiny but incredibly powerful, reducing rotating mass. Every little detail adds up to an engine that makes more power than it should while lasting longer than it has any right to. Now, don't get me wrong, LS engines have their weaknesses. The valley cover plate loves to leak, the knock sensors fail and take out the wiring harness. The oil pressure sending unit leaks on literally every single one. The lifters can collapse if you look at them wrong. The DoD system on the Gen V engines is a ticking time bomb. But these are minor issues compared to the fundamental robustness of the design. You can fix all these problems for less than $1,000 and have an engine that'll outlive you. To be honest, the most impressive thing about LS engines isn't the power they make, it's how easy they make it. No exotic materials, no complex variable valve timing, no direct injection, just good old-fashioned airflow and efficient combustion. A Cathedral Port LS with a cam makes the same power as a Coyote 5.0 with twice the valves and 3 times the complexity. That's not a dig at the Coyote, it's a testament to how good the LS design really is. The Gen 3 engines, which everyone considers obsolete now, are still competitive with modern stuff. An LS1 with heads and cam will embarrass a new Hemi. An LS6 with boost will hunt down GT500s. These are 20-year-old designs competing with current technology and winning. That shouldn't be possible, but here we are. The Gen 4 engines added displacement and better heads, but the basic architecture remained unchanged because it didn't need to change. Let that sink in. GM found a formula that worked so well they barely touched it for 20 years. Sure, they added VVT and direct injection eventually, but the fundamental design, the bore, spacing, the deck height, the cam location, all of that stayed the same because it was right the first time. How often does that happen in automotive engineering? Almost never. The iron block versions deserve special mention because they're essentially indestructible. The LQ4 and LQ9 are identical except for pistons, and both will take whatever abuse you throw at them. Boost, nitrous, RPM, they don't care. The blocks are so strong that people are boring them out to 4.125 inches and making 48 cubic inch monsters that still rev to 7,000 RPM. The main caps walk a little at extreme power levels, but we're talking about 1,500 horsepower here. 1,500 from a truck block. You might be wondering why other manufacturers haven't copied this formula. They've tried. The Hemi has similar displacement, but needs way more cam to make power. The Coyote needs 4 cams and 32 valves to keep up. The Toyota 2UR GSE is a magnificent engine, but costs 10 times as much to build. Everyone else is throwing technology at the problem while GM solved it with good old-fashioned engineering in 1997. Incidentally, the accessory drive on the LS is a work of art. Everything is tucked in tight, the belt routing is simple, and you can remove any accessory without affecting the others. Try that on a modern German V8. The power steering pump delete alone saves 15 horsepower. The AC compressor is mounted up high where it doesn't collect dirt. The tensioner is bulletproof. It's like someone actually thought about working on these things, imagine that. The exhaust manifolds, which everyone immediately replaces with headers, are actually pretty good. They're close to equal length, they have thick flanges that don't warp, and they'll support 400 horsepower without becoming a restriction. Sure, long tubes are better, but the stock manifolds aren't the boat anchors everyone claims. The catalytic converters, however, are trash and should be launched into the sun. They're the single biggest restriction in the entire system. Fast forward to today, and LS swaps have become so common they're almost boring. Miata? LS swap it. 240 SX? LS swap. BMW? LS swap. Porsche? Why not? The engines are compact enough to fit almost anywhere, light enough to not ruin weight distribution, and powerful enough to transform any car into a monster. The aftermarket support is infinite, the knowledge base is comprehensive, and the results are predictable. It's paint-by-numbers hot rodding, but it works. The most ridiculous part is that GM keeps making the LS architecture better. The LT engines, which are technically Gen V small blocks, are LS engines with direct injection and VVT. They make even more power, rev even higher, and somehow get better fuel economy. The LT1 makes 460 horsepower and gets 30 mpg highway. That's hypercar power with Camry fuel economy. The LT4 makes 650 horsepower supercharged and runs all day at that power level. The LT5 makes 755 and comes with a warranty. What they didn't know, however, was that they were creating a monster. The original brief for the LS1 was simply to create a lighter, more powerful replacement for the LT1. Nobody asked for an engine that would dominate motorsports for the next quarter century. Nobody specified that it needed to handle 4-digit horsepower. Nobody required it to be the last pushrod V8, standing in a world gone DOHC crazy. But that's what happened. Admittedly, there's something deeply satisfying about the simplicity of it all. 2 valves per cylinder, 1 cam in the block, push rods and rockers. The same basic layout Henry Ford would recognize. Yet it makes more specific power than most modern engines and does it while burning regular unleaded and lasting 200,000 miles. It's a testament to the idea that simple done right beats complex done wrong every single time. The tuning community figured out the LS secret sauce pretty quickly. These engines want timing, lots of timing. Stock tunes are conservative, pulling timing for emissions and warranty reasons. Add a few degrees across the board and power jumps 20 horsepower. Lean them out slightly and there's another 15. Raise the rev limit 500 RPM and the power band extends beautifully. The stock calibrations leave so much on the table that a tune alone is worth 40 horsepower. My best guess is that GM engineers knew exactly what they were doing. They built in massive safety margins knowing that hot rodders would push the boundaries. They made the rotating assembly strong enough for boost, knowing that turbos would get cheap. They made the heads flow more than necessary, knowing that cams would get more aggressive. They future-proofed the design without admitting it. Perhaps unsurprisingly, the LS has become the measuring stick for all other performance engines. Every new V8 gets compared to it. Every swap candidate gets weighed against it. Every build thread has someone asking why you didn't just use an LS. It's become the default answer to every performance question, and honestly, it's hard to argue with the logic. Why spend 20 grand building a motor when a Junkyard LS with a cam makes the same power. The really tragic thing is that we'll probably never see another engine like this. Emissions regulations, fuel economy standards, and the push toward electrification mean the days of the overbuilt pushrod V8 are numbered. The LT might be the last of its kind, the final evolution of a design that dates back to 1955. When it's gone, we'll be left with turbocharged 4s and electric motors, which might be faster, but will never have the soul of a cammed LS at full throttle. Sometimes I wonder what would have happened if GM had been honest about the power numbers from the beginning. Would insurance have killed sales? Would the EPA have cracked down harder? Would Ford and Dodge have responded differently? We'll never know, but I suspect things would have played out exactly the same way. The LS was just too good to fail, regardless of what the marketing department claimed. The fact is, bone stock LS engines make too much power because GM accidentally built a race engine and sold it as a passenger car motor. They over-engineered everything, underrated the output, and created a legend in the process. Every time someone dynos a stock LS and finds 40 more horsepower than advertised, every time a junkyard motor survives 20 pounds of boost, every time a mild cam transforms a grocery getter into a street terror, the legend grows. One can only imagine what GM could do if they actually tried to build a no-compromise performance engine without any regard for cost, emissions, or fuel economy. The closest we got was the LS7, and that thing was a 505 horsepower, naturally aspirated monster that revved to 7,100 RPM and got 20 mpg, with push rods. In 2006, if that's what they can do with one hand tied behind their back, imagine what's possible with both hands free. But I digress. The real lesson here isn't about push rod versus overhead cam or old tech versus new tech. It's about execution. The LS works because every single component was designed with a purpose, manufactured with precision, and assembled with care. There's no magic, no secret sauce, no unobtainium materials, just good engineering done right, over and over, millions of times, until it became impossible to ignore. The Coyote guys will argue their engine is better, and in some ways they're right. The Hemi guys will point to displacement, and fair enough. The import guys will talk about specific output and efficiency, valid points all. But when you need an engine that makes power reliably, cheaply, and repeatedly, there's only one answer. And that's why LS engines make too much power, even bone stock. They were built to a standard that everyone else is still trying to match, and they did it with technology from the Eisenhower administration. In any case, the next time you see a 4th-gen F-body at a stoplight, remember that you're looking at a factory sleeper. That tired-looking Camaro with the faded paint and questionable panel gaps is probably making 50 more horsepower than the sticker claimed. That stock-appearing Corvette is likely putting down numbers that would have required race gas and slicks 20 years ago. These aren't modified cars, they're just LS-powered, and that's enough. History has a sense of humor about these things. GM spent decades building small blocks that needed extensive modification to make serious power, then accidentally created one that makes too much power stock. They tried to hide it with conservative ratings, but the dyno doesn't lie. They tried to contain it with warranty restrictions, but hot rodders don't care. They tried to replace it with more complex designs, but simple and good beats complex and adequate every time. Maybe that's the real tragedy here. We had the answer in 1997, and we've spent the last 25 years pretending we didn't. Every manufacturer chasing complexity, adding turbos, and hybrid systems and cylinder deactivation and direct injection, when a simple pushrod V8 with good heads and the right cam timing makes all the power anyone actually needs. Sure, a new M5 makes more power, but it needs 2 turbos, 32 valves, and enough computers to run a space station. The LS makes 90% of that power with stuff Henry Ford would recognize. Additionally, there's something deeply American about the whole thing. Take a simple concept, execute it well, build it strong, and let the owner figure out the rest. No nanny-state electronics, no complex service requirements, no dealer-only programming. Just an engine that does what engines are supposed to do: convert fuel and air into noise and speed. The fact that it does it too well is just a bonus. So, yeah, LS engines make too much powerbone stock. They always have, they always will, and GM will probably never admit it. The lawyers won't let them, the EPA would have a field day, and the insurance companies would lose their minds. But every time someone throws a stock LS on a dyno and watches it exceed its rating by 15%, the truth comes out. These engines are overachievers by design, sandbaggers by necessity, and legends by accident. The only problem was that once this secret got out, everyone wanted one. Prices for LS engines have skyrocketed. Even Junkyard LM7s cost twice what they did 5 years ago. The days of the $500 turbo LS build are over. But even at current prices, they're still the best bang for the buck in performance engines. Where else can you get 500 reliable horsepower for under $5,000? Nowhere, that's where. Ensuring for the time being that the LS remains king of the power per dollar hill, GM has kept the architecture alive in the LT. Direct injection adds complexity, but also adds power and efficiency. VVT helps the cam act bigger than it is. Cylinder deactivation is trash and should be deleted immediately, but the bones are still good. The LT is an LS with a graduate degree, more sophisticated but fundamentally the same. A part of me hopes that someone at GM is secretly working on the ultimate evolution of this design. No emissions equipment, no fuel economy targets, no lawyers involved. Just engineers given free rein to see what's possible with pushrod technology. It'll never happen, of course, but imagine an LS with no limits. Billet block, forged everything, roller rockers, solid lifters, the work. It would probably make 1,000 naturally aspirated horsepower and still idle like a stock motor. Think about that for a second. We're living in the golden age of pushrod V8s, and most people don't even realize it. These engines are better than anything that came before, and probably better than anything that'll come after. They're the perfect combination of old-school simplicity and modern precision. Strong enough for boost, but efficient enough for daily driving. They're too good, really, which is why the title of this piece isn't clickbait. Eat it. Lockheed, your fancy engineers with their slide rules and pocket protectors couldn't design something this good if they tried. GM's truck engine department accidentally created the ultimate performance platform while trying to meet fleet fuel economy standards. Sometimes the best ideas come from necessity, not intention. The LS is proof that constraints breed creativity and that good engineering transcends its original purpose. Never heard of it? Well, now you have. The LS makes too much power stock because it was designed with massive safety margins, executed with precision, and refined over millions of production units. It's not magic, it's math. Big ports plus efficient chambers plus good valve timing equals power. The fact that GM underrated them just makes the surprise that much sweeter when you strap one to a dyno and watch it embarrass its official rating. Well, there you have it.